I think somewhere along the line, model engineering has lost its way a bit. All too often you hear about these guys that buy very expensive tooling to do simple jobs. Good example is cutting gears. If you buy a full set of gear cutters, it'll set you back a pretty penny, but you actually don't need to. It will be perfectly acceptable in a home workshop to cut gears with, well, not buying anything. In this video, I'm going to show you how to do that. And I'm going to show you how to do the keyway in the middle of the gear without buying an expensive brooch. All with stuff lying around the home workshop, with nothing fancy, just using bits and pieces. I hope you guys enjoy this video. Something different.
Oh dear. So let's have a look at a little bit of theory for gears. And I'm not going to go into Hertzian contact and stresses in gears and all sorts of stuff like that, because let's be honest, an online gear solving program will do that for you. So the chances are you don't need to worry about it. There is, however, one parameter that you do need to worry about in the home workshop, and that's the gear modulus. Now, in simple terms, all that a gear modulus does is it makes sure that adjacent gears mesh properly. And in theory, it's just a ratio of the pitch diameter to the number of teeth. Now, think about that for a second. If you have a uniform gear modulus, it just tells you that a very large gear will have far more teeth for a given pitch diameter than a smaller gear will have a lot less teeth. And then you know that your teeth are more or less the same size. Now, what happens in industry is your gear modulus cutters are to a certain degree standardized. So you get sort of 1, 1.5, 2, 2.5, and so forth. And they've standardized in industry so that all gears are cut to a standard sort of gear tooth profile. Unfortunately, what that creates is it creates very odd gearing ratios. If you have a look at a gearbox of a car, you'll notice that a lot of the gears are very weird ratios. It'll be like 2.01 and 1.07 and so forth. But in the home workshop, your gear modulus can be whatever you want it to be. In this example, I wanted a gearing ratio of 2 exactly. What that does is I'm now able to use one change gear to cut both of my gears.
So this is the smaller gear. It is a 24 tooth, and I'm using a large change gear of the lathe, which is a 48. So I'm skipping every second tooth. And check how easy it is to index for cutting the gear. Just like that. And drop the table down to 0. And what I always do is I just run it once, and it needs to just touch, and then I know that I'm back on 0. Now I'm doing quite big cuts. I'm doing 1.5 mil cuts, and the gear profile is about 3.3 down. So there's only 3 cuts per gear. So this actually goes really quickly. And everyone says, yeah, a single tip tool doesn't cut nicely, but look at that. I mean, so now we're doing another 1.5 mil cut. And I've got a hand feed, and typically what I do is I actually listen to the tool. See there, it's got a different sound. And that's the feed that I'm looking for. So these are big chips. These are 1.5 mil feed, but it's 3 millimeter down. So it's cutting the whole profile. And then right at the end, I just do a very small finishing cut of 0.3. And that just cleans up the tooth nicely. So incidentally, I'm cutting 2 gears at once, and I would do that. I would recommend doing that anyway because it saves you a whole lot of time, but also there's a lot more support and you're getting a nice cut on your tool. Just like that.
Then finally, I promised to show you guys how I do the keyways for my gears. And I use the exact same method for the keyways in the larger wheels of my loco. I do this on my lathe, and I've made a planing attachment that just attaches to my lathe. Each stroke of the tool typically cuts between 0.1 and 0.2 millimeter, and that feed is governed by the cross slide and the dial gauges and so forth. That's really, really easy to do. Cutting a keyway on a relatively large wheel, or this sort of keyway in this gear, will only take about 10 minutes. It really is a very quick and easy process, and it is way cheaper than buying an expensive broach. Guys, all the tooling that I've showed in my video, I will be putting on Patreon. If you want to download them and give it a bash, see if it'll work on your machines, please do. I hope you enjoyed this video. Thank you so much for watching. Enjoy machining. Cheers, guys.